problem 5 is asking us to find the maximum and minimum of this function given this constraint right here, the y equals x squared plus 1. So here we go. We have to remember that there is the Lagrange multipliers method and there is the substitution method. So you ask yourself, which one would be most appropriate for this problem? And my answer would be substitution. The reason why: you always use substitution whenever you can solve your constraint for a variable. And this one's already solved. At least that's the first method you want to try. If you get stuck, you may want to go back to Lagrange. But anyway, so this one's solved for y. We're going to go with substitution. So I am going to substitute in for y into my function, which will leave me with negative 6x cubed plus x squared plus 2 times x squared plus 1 squared. Now, you'll notice I'm actually no longer have a function of y, I only have a function of x. So really, if I ask you to find the partial derivatives, you're really just finding the derivative of f with respect to x, and you're done. So, whoops, and excuse me, let me bring back up. There we go. So all we're going to do here is do our derivative. So this is going to be negative 18x squared plus 2x. Now here we have a bit of a chain rule. That's okay. So that's 4 times x squared plus 1. And then times the derivative there, so 2x. Now, if you need to, you can simplify this out a little bit. Remember, we're going to set it equal to 0, so that way we're finding the min or max. So if you want to clean this up a little bit, you can. So this is going to give us plus 8x cubed plus 8x. There we go. Now combine your like terms. So 8x cubed, there we go, minus 18x squared plus 10x. Now to solve this problem, please factor out a 2x. It makes your life so much easier. So that gives us 4x squared minus 9x plus 5. And here's where the fun begins. We say to ourselves, how do we solve this? Well, 2x equals 0, which just means x equals 0, is one of our solutions. Now, another solution is going to come from 4x squared minus 9x plus 5 equals 0, and you can either factor it or use the quadratic formula. So I don't see how to factor it very quickly off the top of my head, so I'm just going to jump straight into quadratic formula and not waste too much time. So it's negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And as I work through this, I am going to end up seeing that this, 4 times 5 is 20, 20 times 4 is 80, so 81 minus 80, that's just 1, square root of 1 is 1, divided by 8. So this is going to end up giving me x equals 10/8, or x equals 1, 8/8. I guess I can do it step by step. Ooh, something strange just happened. There we go, got it cleaned up. So that's going to give me 8/8. So now I could just simplify this down to make it 5/4, or x equals 1. So now I have 3 answers. I have the answers of x equals 0, x equals 1, or x equals 5/4. So now I have to kind of work backwards, and I substitute them back into my y equals, which is y equals x squared plus 1. So now I know y equals x squared plus 1. So when I substitute in 0, so for the case where x equals 0, I'm going to get y equals 1. For the case where x equals 1, I'll get y equals 2. And then finally, for the case where x equals 5/4, I'm going to get something not as pretty. We get y equals 41/16. And now for each of these answers, I need to take them and plug them back into the original equation right here. So there we go. So it was negative 6x cubed plus x squared plus 2y squared. So now I substitute in the values for each of my points to find their z values. So f of 0, 1 will give me, I believe it's 2, because it would be 0, 0, yep, 2. F of 1, 2 would be not as easy to do in my head, but still not terrible, because it would just be negative 6. This is going to be negative 6 plus 1 plus, and then 2 squared is 4. 4 times 2 is 8. So negative 6 plus 1 plus 8, that just makes 3. There we go. And then the third point, f of 5 fourths, 41 sixteenths, not nearly as much fun. I'm using a calculator. That comes out to be 381 128ths, or as a approximation, it's 2.977-ish. And why we care? Because the problem really just asks for us to find the min and the max. And right now, we can see them. We don't need a d-test. I can tell you right now, the biggest output value I'm going to get is a 3, so therefore this part is the max. And the smallest output I'm going to get is the 2, so there is my min, and everything else in between is a who cares. So therefore, I can now safely say, I have a min of 2 at 0, 1, and a max of 3 at 1, 2. Okay, I hope that helped out.